Welcome to EDU World Space.
In this video, we're asked to use Simpson's rule in order to approximate the surface area obtained by rotating a certain curve around the x-axis. When we do that, we're going to have to set up the integral first. And in order to do that, we'll just use the green formula that I wrote down. So, what we ought to do is to first find the derivative of our function. So, if we have y being equal to x times the log of x, where, again, the log denotes the natural logarithm, then we have, by the use of the product rule, we have the derivative as just being 1 plus log x. You can verify this to be true. Now we can substitute all of this into our integration formula. So that our integral will become the integral from 1 to 2. We'll have 2 pi times y, which is just x times natural log of x, times square root of 1 plus log x, the whole thing squared. Now what we're going to do is we're going to let all of the integrand, we're going to let it equal f of x. And we have to remember Simpson's rule now. Now Simpson's rule states that the definite integral can be approximated by a certain multiplying every interval by a certain width divided by 3, but the widths are going to be arranged as follows. Plus 4f of xn minus 1 plus f of xn. Let me make that n minus 2 subscript a little bit cleaner. Where we have to find our delta x, of course, that's just b minus a divided by n. In which case we have 2 minus 1 over 10, which is about 0.1. We're given these bounds earlier. This is going to be this is going to make our calculations a lot easier. We'll approximate then our surface area will be approximately 0.1 over 3 times f of 1, using our definition of the function we defined earlier, plus 4 times f of 1.1, plus 2 times f of 1.2, plus 4 times f of 1.3, plus 2 times f of 1.4, plus 4 times f of 1.5, plus 2 times f of 1.6, plus 4 times f of 1.7, plus 2 times f of 1.8, plus 4 times f of 1.9, plus f of 2. And you can evaluate this in your calculator. And what it gives us is it will give us this approximation will give us 7.24893. And if you type this into Wolfram Alpha or something, you'll get approximately the same. The same as with Wolfram Alpha. And that's how I do this question.